In this lesson video, we're going to begin Unit 8, and we will be talking about the Day 1 lesson over linear equations. Okay, this is going to review some content. Hopefully you remember some of this from Algebra 1, but we're going to be talking about linear equations, and one of the first things we identify with linear equations is the idea of what slope is. Remember that slope is rise over run. Okay, or the rise values are the difference of the y values of 2 points, and the run would be the difference of the x values. So when we say that we do rise over run, that creates two special cases sometimes. One of those being if there's no slope, and often instead of saying no slope, we say there's a zero slope, because their slope would equal 0. That would be when the rise is 0 and the run is any other number. Okay? When we have 0 on the bottom of a fraction, though, if the run is 0, so any number over 0, that creates a mathematical conundrum where we cannot actually divide by 0. If you tried to divide it by 0 in a calculator, you would get an error message. It's because there is no mathematical definition for dividing by 0. So we say that the slope is undefined. Okay? And when we identify our slope-intercept form then, we have an equation in this form where this m represents your slope and this b represents the y-intercept, which the y-intercept is always whatever y value we have when x is 0. And that makes sense. If I put in 0 for x here, that whole term goes to 0, and the only thing left that y could equal is whatever b is. So that's your y-intercept. But we also have another form of writing linear equations, and that's the idea of point-slope form. In point-slope form, we still have our slope, but then we have it written a little differently so that I can express it as the difference between two y values and two x values. So this x1, y1 represent any point on that line. x1 and y1 are just the coordinates of a point that is on the line, and m is still your slope. And then we have another form of this equation called standard form. So linear equations can also be written in standard form. This one's going to be a lot different. This is where these values a, b, and c are considered integers, and the first one in front of x, a, is always a positive number greater than 0. Okay, so as we go through some examples of finding slope from the given information, we have a situation where you could have the given 2 points like this. So your slope would be the difference of those y values, so it'd be like 2 minus 4, over the difference of the x values, 7 minus 3. 2 minus 4 would be negative 2, 7 minus 3 is 4. That fraction can be reduced to negative 1/2. Even if I were to get a positive over a negative, just remember that is still a negative value. If I asked you to identify the slope here, that's just the number in front of the x. That's the y equals mx plus b form, so your slope is 2/3. The same can be said of this next equation. When it's in point-slope form, you still have a slope that's part of that formula, so the slope here is just 1/2. But to find the slope from an equation in standard form, you have to put the equation in the correct form first. So we're going to put this into slope-intercept form. That means I want to turn it into y equals mx plus b. So I'm first going to subtract the 3x from both sides, because ideally I want to get the y all by itself on the left. This gives me the equation 4y equals negative 3x plus 12. I want to put my minus 3x in front of the 12 so that I can get it looking more like slope-intercept form. And the last step is to divide by that 4 everywhere to cancel it out. So my equation is actually y equals negative 3/4 x plus 3. So there's your slope. The slope for this one is negative 3/4. Now what you might start to recognize in standard form, what that gives you is actually something you could figure out from that equation. -3 is the opposite of this a value, so your slope when it's in standard form is always -a over the b value. So the slope from standard form is always just -a over b. That lead coefficient in front of x, make it the opposite, over whatever is in front of the y, and then reduce. Okay? So we say that linear equations have a constant rate of change. That rate of change is your slope. That's another thing we can use to determine what slope is. It's called a rate of change. So we're going to talk about writing rate of change or slopes from this information, but we're going to write each of these equations in slope-intercept form. We're going to put every equation into this form. Y equals mx plus b. Every equation is going to be in that form for these examples. So if we are given standard form, you can do that like we just did a second ago, or you can even take that shortcut. It's the opposite of a over b. If I do minus 4x, that gives me a -4. So 3y equals -4x plus 9. And divide by the 3, it goes over b. There's your slope. So, but in our instructions, we're told to actually write the equation. So our equation is y equals -4/3 x, and then 9 over 3 simplifies to +3. Okay, so if you just wanted to find the slope, you can kind of use that shortcut I showed you. But if you need to write the full equation, then go ahead and complete that work. Okay? For part B, if you're given 2 points on the line, the first thing you need to do is find the slope. Okay, step 1 is to just calculate the slope. Slope is rise over run. That's difference of the y's. So 8 minus -2 becomes 8 plus 2 over 5 minus 7, which would give me 10 over -2, which would be -5. So I know my slope is going to be -5, and then I get to pick either one of these to help me find what b is. Because if I went to plug into this formula, y equals -5x plus b, I've got to figure out what b is. To figure out what b is here, I need to plug in an x and a y so that I only have that b as the variable. Well, I can use either one of those ordered pairs. I'm going to use this one. So instead of y, I'm going to replace it with an 8. So this is step 2. And then I leave my -5 for my slope. And instead of x, I can plug in a 5. And then I do my plus b. And then we just solve. -5 times 5 is -25. And then I add the 25 to both sides here. And we get 33 for that b value. So my equation goes back to y equals -5x plus 33. Okay? To write the slope-intercept form given a graph, this is probably the easiest thing to do. You need the slope, which is rise over run, and you need the y-intercept. It actually helps to figure that one out first. The y-intercept is where it crosses the y-axis, where x is 0. That's that point, so the y-intercept is 4. And then just use rise over run to go to a second point, like this one. Well, that would be a rise of 2 over a run of 1. Or if you're looking at the actual numbers, that would be a rise of 4 over a run of 2, but that still simplifies to a slope that equals 2. So I just plug those into the equation. Y equals 2x plus 4. Okay, you can also find the slope-intercept form of this line given a table, kind of like we did when I had 2 ordered pairs. Well, now with this table of values, I actually have 5 ordered pairs. Every row is an ordered pair, but I want you to pay careful attention to this row. That's when x equals 0. That is the y-intercept. That's b. So I know it's going to be y equals something times x minus 1. And I just have to fill in the slope now. To find the slope, just do your rate of change of your y's compared to the rate of change of your x's. Okay, you can do that there, or you can look down here. It doesn't matter. But you want to use that same repeating pattern. So every one of the increase in y values is going up 3. We would add 3 each time I do that here. And for every time I add 3 for the y's, I'm adding 1 for the x's. So the change in y values is a plus 3. The change in x values is a plus 1. That simplifies to a slope of 3. So our equation is y equals 3x minus 1. Okay? Keep rolling right along. In this situation, we have a computer technician that charges a one-time fee of $50 plus an additional $20 per hour for labor. Okay? Anytime you have a word problem that is supposed to be a linear relationship, we have a rate of change. The rate of change is almost always identified by this word, per. It's one amount per another amount. You're giving a rate of comparison between two values. So that is your actual slope. Your slope is $20 per 1 hour, or just 20. That means the other number here is most likely the y-intercept. And let's think about that. The y-intercept is when the x value equals 0. Well, that's this one-time fee that the computer technician charges, because it doesn't matter how many hours of labor there are, you're going to pay the $50 to this computer technician, even if you have 0 hours of labor, in theory. Okay, so this is your b value. So our equation is y equals 20x plus b, where x is the number of hours of labor and y is the total cost. Sorry, not plus b. We know what b is. B is 50. Okay? For this situation, Luke has a $20 gift card. He can download songs for $1.50 each. T is the total on the gift card, and D is the number of songs downloaded. This situation calls for its own variables. So instead of y, we're going to use T. And instead of x, we're going to use D. So instead of y equals mx plus b, we're going to use T equals m times D plus b. I just replaced the x and the y with what they are being represented as. When you have a specific variable used in the word problem, you need to use those variables in your answer. Okay? So this time Luke has $20 on his gift card, but he's going to be charged $1.50 for each download. Well, that's your rate of change, but it's not a positive rate of change. You are decreasing the amount on the card every time you download a song, or Luke is here, so that's a minus 1.5. So my equation will look like this. The total on the card will be a negative $1.50 times each download D, plus the original starting amount on the gift card, which was $20. Okay? All right, let's go right along into another few examples. Now that we've identified how to write equations of lines, we need to identify relationships between more than one line. And those relationships are either parallel or perpendicular. We say that two lines are parallel or two lines are perpendicular based on their slopes. Okay? When I have parallel lines, if I look at these two examples here, the slope of line A is rise 2, run 1. Or just 2. And if I look at the slope of line B, that's rise 2 and run 1 as well. So since they have the same slope, that means they will never intersect. They are parallel. So this is what I want you to write down. Parallel lines have the same slopes or equal slopes. That means they will never intersect because as one rises and runs a certain amount, the other rises and runs the same amount. They're following the same pattern. So perpendicular lines eventually will intersect, but they intersect at right angles. In order to assure that they intersect in right angles, we need to look at their slopes. So again, I'm going to look at the slope of line A. Okay, that would be a rise 2, run 1, which would be 2. But I want to compare that to the slope of line B. Slope of line B, if I want to use two other points, is going to go a rise of negative 1 and a run of 2. Well, that slope is not the same as the other slope because they intersect. But the relationship between those slopes is something that we call opposite reciprocals. Okay? When we have perpendicular lines, we say they have opposite reciprocal slopes. Okay, perpendicular lines have opposite reciprocal slopes. Opposite means from positive to negative or vice versa. Reciprocal means you flip the fraction. So from A over B to B over A. So if I have two slopes where one is positive, one is negative, and one is a flipped fraction of the other, we say they are opposite reciprocal slopes, therefore the lines are perpendicular. So we're going to take some time to determine those relationships. So here's what we're going to do in example 2. We want to find the slope and identify if the following, like A, B, C, and D, are parallel or perpendicular. If they are neither of those, we just write neither. So we're looking for these relationships. Okay? So let's identify the slope of this equation. Well, it's pretty straightforward. Your slope is in that formula already. It's in that equation. Your slope is 1/2. So I'm going to compare all of my other slopes to that. The slope of this line is negative 1/2. Well, that is the opposite of 1/2, but it's not the reciprocal. Since it's not both opposite and reciprocal, we say that these lines are neither, meaning neither parallel or perpendicular. As we move on to the next one, this is not written in slope-intercept form, but remember, in standard form, the slope is the opposite of A over B. Well, that would be negative 2 over 1. And if you aren't sure about how to just see that, you can always just solve the equation for y. So do minus 2x from both sides. So y would equal negative 2x minus 4, and there's your slope, negative 2. So this slope is negative 2. Negative 2 is the opposite of 1/2, and it's the reciprocal of 1/2. So these are perpendicular lines. Okay? For parts C and D, what I want you to do is I want you to pause the video and try and find the slope using those two sets of ordered pairs and tell me the answer. Are they parallel, perpendicular, or neither? Okay, if you need more time, pause the video again here. Otherwise, these are the answers you should get. From A to B, that has a slope with a rise. If I do 3 minus 1, that's 2. And run would be 10 minus 6, that's 4. That's a slope of 1/2, which is the same as my other line's slope 1/2. So these are parallel. And then for D, if I do my rise over run, that's 7 minus negative 5, or 7 plus 5. And then for the run, that would be 8 minus 2. So that would be 12 over 6, which is a slope of 2. Now that is the reciprocal of 1/2, but it's not opposite. So since it's not both of those, we again say neither. Okay? And then to finish this up, you're going to be given some instructions about how to write an equation of a line that goes through a certain point and is either parallel or perpendicular to the given line based on what the instructions tell you. Your final answer should be in slope-intercept form. So to do this, we're actually going to use point-slope form. We're going to take our y minus y1 equals m parentheses x minus x1, and we're going to turn that into my final answer in slope-intercept form, y equals mx plus b. So to do that, you need to recognize the given point they show you is your x1 and your y1, and then the slope comes from these two parts. So I give you a line to use. In this case, the slope is -2. The slope is -2. But we want a line that is perpendicular to that. So our perpendicular slope is the opposite reciprocal of -2. That would be +1/2. So that's what I'm going to use in my equation. Okay, I'm going to use my m of 1/2, and I'm not going to use this +5 at all because I want a different line. It's going to have a different y-intercept then. So I'm going to go to my point slope form. That's this one. I'm going to write in that form first. So I'm going to do y minus the y1 coordinate, which was 8, equals this new slope of 1/2 times x minus the x coordinate. The x1 I'm using is 4. And then I just have to change this equation into slope-intercept form. To do that, the first thing you need to do is get rid of the parentheses, and then next you'll get y by itself. To get rid of the parentheses, you have to distribute. So y minus 8 would actually equal 1/2 x minus 2. When you distribute 1/2, you get 1/2 x minus 2. Then we can add 8 to both sides. And my final answer is y equals 1/2 x plus 6. Okay? For the next one, we're going to do the same thing, but the key phrase here is parallel to this equation. Well, that means it needs to have the same slope. This slope of this line is 1/3, so I'm going to use the same slope. My parallel slope is also 1/3. So again, we go to point slope form first. Your x1 and your y1 are here, so we're going to do y minus 7 equals 1/3, parentheses, x plus 3, because it's minus -3. Then we're going to distribute the 1/3 to both of those. So we get y minus 7 equals 1/3 x plus 1/3 of 3 is like doing 3 divided by 3. That's just 1. Then we're going to add 7 to both sides. And your final answer in slope-intercept form is y equals 1/3 x plus 8. And this finishes the lesson video for Unit 8, Day 1.